So here are some properties of integer multiplication. If I have two integers a and b, if a and b are both greater than or equal to 0, or a and b are both less than or equal to 0, then their product, a times b, is equal to the same product that you get when you take absolute value of a times absolute value of b. In particular, this means that the product is positive or non-negative. If one of A or B is less than 0 while the other is greater than or equal to 0, then the product A times B is negative the absolute value of A times the absolute value of B. We have some properties of integer multiplication. These should look similar to the properties that we saw with whole number multiplication. So if I have integers A, B, and C, then a times b is a unique integer. That's the closure property of multiplication. Multiplication is commutative over the integers, so a times b is the same as b times a. It's also associative, so I can first multiply a times b and then multiply by c, or I could first multiply b times c and then multiply a times b times c. There is an identity for multiplication. 1 is the unique integer such that for all integers a, 1 times a gives me a back, and that's the same if I multiply on the other side, so a times 1 is also a. We have a new property, the distributive property of multiplication over addition for integers. So a times the quantity b plus c is the same as a times b plus a times c. And we can also distribute on the right. So the quantity b plus c times a is the same as b times a plus c times a. The zero property holds for multiplication over the integer. So if I multiply any integer by 0, I'm going to get 0. And here are some new properties. So if I multiply negative 1 times any integer a, I just get negative a. If I multiply negative a times b by the commutative property, that's the same as b times negative a. And that's the same as the negative of a times b. And finally, if I multiply negative a times negative b, I get the same thing as if I multiplied a times b. We can also distribute over subtraction. So a times the quantity b minus c is the same as ab minus ac. And the quantity b minus c times a is the same as ba minus ca. Okay, so let's try applying some of these properties. So I have negative 3 times the quantity x minus 2. And I'm allowed to distribute that negative 3 in. So that becomes negative 3 times x minus negative 3 times 2. And that's the same as negative 3x plus 6. What about a plus b times a minus b? I think I have this one in the slides. So we're going to use the distributive property first to distribute this a plus b over the a minus b. So that's a plus b quantity times a minus the quantity a plus b times b. And now I'm going to use the right distributive property to distribute on the right of each of these. So I get a squared plus ba minus the quantity ab plus b squared. We saw before that subtraction can be rewritten as plus the negative. So that's what we're doing in this next line. And then we're going to distribute that negative in on the next line. And finally, we see that we've got an AB plus a negative AB. And remember that is equal to 0. So we get 0 here. And I have an a squared plus a negative b squared, which simplifies down to a squared minus b squared. This form is called the difference of squares formula. So in general, if I have a difference of squares, so an a squared minus b squared it factors as the quantity A plus B times the quantity A minus B. So let's use that formula to simplify some things. So here in part A, my A is 4 and my B is B. So the difference of squares formula says that this multiplies to give me 4 squared minus B squared, which is 16 minus B squared. In part B, I have negative 4 as my A, and again B as my B. So this is also of the form A plus B times A minus B. And since that factors it, or multiplies to give you A squared minus B squared, this is going to be negative 4 squared minus B squared. And negative 4 squared is negative 4 times negative 4, which is positive 16. Now what about part C? Well, this is no longer of the form A plus B times A minus B. Instead, what I have is something squared minus something squared. So this is actually of the form A squared minus B squared. And our difference of squares formula says that this factors as A plus B times A minus B. So here I want to treat x plus 3 as my A and x minus 3 as my B. So this is going to factor as x plus 3 plus x minus 3, that's my A plus B, times x plus 3 minus the quantity x minus 3. That's my A minus B. And we can clean this up a little bit. So I'm going to have an x plus an x, that's 2x. And then a 3 minus a 3 gives me 0, so just 2x for that first term. And the second term, let's distribute that negative sign in first. So I could distribute this and get minus x plus 3. And so here the x's are going to cancel, and I'm left with 3 plus 3, that's 6. So I have 2x times 6, and we can multiply the 2 and the 6 to get 12 times x. Okay, so this was a much more complicated way to write just 12x. When we write our distributive property of multiplication over subtraction in reverse order here, so I have AB minus AC is the same as A times the quantity B minus C, and similarly in the second equation. We can also do that with addition, right? We can just change these signs to addition, and these are also true. These are called factoring, right? The expressions on the right are in factored form. The common factor A has been factored out of each term on the left. Both the difference of squares formula and the distributive properties of multiplication over addition and subtraction can be used to help us factor. For example, let's try factoring some problems. Okay, so my first example, part A, is x squared minus 9. So I should recognize this as a difference of squares. I have x squared minus 9 is the same as 3 squared. And now this factors by my difference of squares formula as x plus 3 times x minus 3. What about part B? Again, I have a quantity squared minus a quantity squared. So this is a difference of squares. And my difference of squares formula says that this factors as A, so x plus y, plus b, so plus z, times my a, x plus y, minus my b, which is z in this case. What about part C? In part C, I don't have any squares, so this isn't a difference of squares problem, but I do have some common terms, right? There's an x in both terms, and so I can factor that x out, and I'm left with negative 3 plus 5y. So this factors as x times negative 3 plus 5y. What about part D? Well, I should think of 6 as 3 times 2. So that means that each term has a factor of 3 that can be pulled out front, and I'm left with x minus 2. So 3 times x minus 2. And finally, for part E, both terms have an x squared, so I can pull the x squared out, and I'm left with 5 minus 2. I'm thinking ahead. And 5 minus 2 is 3. And generally, we like to write the integer first. So that's the same as 3 times x squared.